San Francisco's steep streets are world famous. But surprisingly, the steepest street in the world is not in the American city. It's across the Pacific Ocean, in a little-known university town called Dunedin, on the South Island of New Zealand. Baldwin Street is a short residential street, approximately 3.5 kilometers north of Dunedin city centre. The 350-meter-long street is, according to the Guinness World Records, the steepest drivable street in the world, with a gradient of 35%.
Hey guys, and welcome back. So today we are looking at inverse trig ratios, and we just saw a short video about the steepest street in the world. And yeah, I would have thought that it was in San Francisco as well, but actually it's in New Zealand. And one of my best friends, one of my longest friends, I've been friends with her for over like 21, 22 years. We went to kindergarten together. She was just there, and I was just like, there's no way that San Francisco doesn't have the steepest street in the world, and well, I was wrong. So, anyways, we will get to see why we are looking at the steepest street in the world by the end of this lesson. So, the objective of this lesson is I can use inverse trig ratios to find the missing angle measures. Okay, but before we start finding angle measures, let's just do a quick review so let's find sine of x. Sine of angle x. So sine of angle k. So here's angle k. And so sine is opposite over hypotenuse. So sine k is equal to 11 over 61. Okay? Opposite over hypotenuse. But now let's find the measure of angle k. So the measure of angle k, well, we know sine. We know that sine k is equal to 11 over 61, but we actually don't know what the measure of angle k is. It has to be a certain number, but we don't know what it is. So there are multiple functions that undo each other. So we need to find a way to undo sine k equals 11 over 61 to figure out what the measure of angle k is. So like addition and subtraction undo each other, multiplication and division, squares and square roots. And then, so how do we undo trig ratios? Well, so we need to figure out how to find measure of angle k. To use that, you can use the inverse trig function to find the measure of the angle. Inverse trig functions. So, inverse trig functions. So if sine A equals x, like if sine k equals 11 over 61, then inverse sine or arc sine of x equals measure of angle A. So if you know the ratio of the sides for sine, then you can find the measure of the angle. Same goes for cosine and tangent. So if you know the adjacent and the hypotenuse, then you'll be able to use inverse cosine. And if you know the opposite and the adjacent, then you'll be able to use inverse tangent to find the angle measure. So it still might be a little bit fuzzy at this point, but let's take a look at some examples to hopefully that it will clarify this a little bit more. So let's go back to our original problem, finding the measure of angle k. So we still know that sine k is equal to 11 over 61. So sine k is 11 over 61. But now we want to find this angle measure. So we're going to use inverse sine. So sine to the negative 1 of 11 over 61 equals the measure of angle k. So to put this in your calculator, if you have one of the yellow calculators, you would literally just put this. You'd go to Trig, and then go down to sine -1, put 11 divided by 61, and then enter. For if you have an iPhone, you would do 11 divided by 61 equals second, and then inverse sine. And I believe you push enter. I'm not 100% sure, because it might already tell you when you push sine. And what you should get, the answer you should get is that the measure of angle K is equal to 10.4 degrees, approximately 10.4 degrees. Whoops. Try not to cross everything out. There we go. 10.4 degrees. So now, use your calculator to find each of these angle measures. I'll give you guys a moment to do that. So arc cosine of 0.87, arc sine of 0.85, and arc tangent of 0.71. So as you see, I'm saying this like cosine to the -1 in different ways. You can say cosine to the -1, you can say inverse cosine, or you can say arc cosine. Same goes for all of them. Just don't say arc cos or arc sin. Don't say that. Sine, cosine, tangent. All right, so arc cosine, we get 29.54 degrees, or approximately 30 degrees. The question's asking us to round to the nearest degree, so since it's 29.5, we round it up to 30. Arc sine of 0.85 ends up being 58 degrees, approximately 58 degrees, and arc tangent of 0.71 is approximately 35 degrees. So now let's solve a right triangle. We were able to solve right triangles when we had one angle and one side length. We were able to use our trig ratios to find another side length and then Pythagorean theorem. But now we only have two side lengths and we need to find everything else. So we can first find the third side length. We can first find ST using Pythagorean theorem. So 5.7 squared equals 5 squared plus the length of ST squared. And so 5.7 squared minus 5 squared ends up equaling 7.49. Then we take the square root of 7.49 and we get 2.74. Okay, so we know that ST is 2.74. Therefore, the measure of angle R should be less than the measure of angle T. So that's just one thing that we can keep in mind. All right, so now we can use, if we want to find the measure of angle R, we know the adjacent side and the hypotenuse. The adjacent side and the hypotenuse. So that means we're going to use cosine. And since we're trying to find the angle measure, we are going to use inverse sine or arc cosine. Sorry, inverse cosine or arc cosine. So we're going to say that the measure of angle R is equal to inverse cosine of adjacent 5 over hypotenuse 5.7. And that is approximately 29 degrees. And since we know that R is 29 degrees, we know that T is going to be complementary to R, and so the measure of angle T is 61 degrees. And then now, for getting back to the whole point of the first video, a highway sign warns that a section of road ahead has a 7% grade. To the nearest degree, what angle does the road make with a horizontal line? Okay, so when you're on the road and you see like 7% grade or 4% grade or something like that, what that means is that for every 100 feet horizontally, the road rises 7 feet. So for every 100 feet you go, so you would have a triangle kind of like this, that for every 100 feet that you go, the road goes up 7 feet. So that is considered a 7% grade. And what we're trying to figure out is what is that angle there. So 7% is like 7 over 100. So there we go. And so we know the opposite side and the adjacent side. So we can do inverse tangent of 7 over 100. And it's approximately 4 degrees. So the angle that is made is approximately 4 degrees. So clearly, this is not the steepest road in the world. The steepest road in the world had a 35% grade.
The steepest drivable street in the world, with a gradient of 35%.
So before you end this video, try to figure out what angle is the steepest road in the world. So you would do inverse tangent of 35 over 100. So let's see what that is. Inverse tangent of 35 divided by 100. And we get about 19.3 degrees. So the steepest road in the world, the steepest road is 19.3 degrees steep. All right, thank you guys. You are ready to try out the online quiz, and then I will see you in class soon. Bye-bye.